Every grid on Earth is chasing the same thing. Power that's there the moment you need it. Not when the wind blows or the sun clears the clouds, but simply on, at 3 in the morning, in a windless January, every day of the year. Engineers call it firm power, and making it cleanly is the hardest problem in energy. Fusion can. Fusion is the reaction that lights the sun. Force light nuclei together, and a sliver of their mass becomes an enormous amount of energy. With no carbon, no chain reaction that can run away, and far less long-lived waste than the fission plants we know today. Kronos Fusion Energy exists to make that buildable. We're a family-owned American company, and our approach is deliberately unusual. 3 machines, 1 purpose: to make what the nation can't source at scale. First the materials, then the power. The idea that organizes everything is that fuel follows purpose, not platform. Build a machine to breed fuel, and it runs the fuel that breeds. Build one to make power, and it runs the fuel that converts cleanly to electricity. So we build 2 kinds. A breeder, Hyperion, whose job isn't electricity at all. It's a foundry. It manufactures strategic materials the country otherwise can't get, including the fuel the other machines need. And a burner, housed as Aegis for defense sites and MetroVolt for data centers, which takes that fuel and turns it directly into firm, clean power. The order matters. The breeder is buildable sooner because a foundry needs fusion gain, not net electricity, a lower bar to clear. It earns its keep making materials, while the burner's fuel supply scales up behind it. Breed, prove, scale. Each step de-risks the next. Here is what makes us different from how fusion is usually sold. We publish the physics, the sensitivities, and the code that reproduces our numbers in the open, where anyone can check them. Every figure carries the condition it depends on, and we label exactly what each claim is. Demonstrated, a target still being verified, or an assumption. We would rather be trusted than impressive. To be clear about what this is, a conceptual design, validated in open simulation. Not an operating machine. Not yet. And we say so every time. We come from people who think in decades, and fusion asks for exactly that. In the films that follow, we open up each machine in turn. Kronos Fusion Energy, engineered in the open. Some materials can't be bought at any reasonable scale. Not because they're expensive, but because almost no one makes them. Hyperion is built to make them. It's a spherical tokamak, a fusion machine shaped less like a donut and more like a cord apple, with the plasma wrapped tight around a slender central column. That shape buys strong plasma pressure at a modest magnetic field, which is how you get a powerful machine that stays compact. A major radius of just 1.2 meters, at an aspect ratio of 2.5. But here's the thing that makes Hyperion buildable now. It isn't trying to put power on the grid. It's a foundry. And a foundry only needs fusion gain. More energy out of the reaction than you put into it. not net electricity for the whole plant. In our reference design, that gain is 3.424, producing 88.7 megawatts of fusion power at a plasma current of 9.86 megaamps, a fraction of what a conventional machine would need for the same duty on the program's own scaling. What does the foundry actually make? 3 materials the nation struggles to source. Tritium, a hydrogen isotope that barely exists in nature, bred by wrapping the plasma in lithium, so the fusion neutrons split it into fresh fuel. Our design targets a breeding ratio of 1.8 and production that stages from 1.7 up to 4 kilograms a year. Helium-3, one of the rarest useful isotopes on Earth, produced as a co-product at roughly 9/10 the tritium mass, and a flood of 14 mega-electron-volt neutrons, the exact brutal environment that the materials of every future fusion plant have to survive, and which there's almost nowhere on Earth to test against. Holding a plasma steady is its own discipline. Hyperion runs with negative triangularity. The plasma's D shape turned inward at a value of about -0.30. A configuration demonstrated to eliminate the violent edge instabilities called ELMs. We treat that as a design lever, not a settled choice. And the final sign of that shaping is a question we keep openly on the table. And when the obvious ways to make the design easier don't actually work, we report that too. Plainly, because a result you can't reproduce isn't a result. Hyperion is the front of the whole enterprise, the machine that earns, and the machine that fuels. Breed first. Everything else follows. 3 materials sit quietly behind some of the most important technologies of the century, and all 3 are desperately hard to get. This is why Hyperion breeds them. Start with helium-3, below about 300,000ths of a degree above absolute zero. It has no substitute. It's the working fluid that cools the dilution refrigerators inside quantum computers. It's also the gas that lights up the lungs in hyperpolarized MRI, showing airflow that a normal scan can't. And it's been formally rationed since 2009, because demand outran the only real supply: the slow decay of aging nuclear stockpiles. Hyperion breeds it as a co-product of fusion, at home. Then tritium. It's the isotope that maintains the nuclear deterrent, and it decays at more than 5% a year, so it has to be continually remade. Today that means a reactor. Hyperion offers a domestic, non-reactor path, building toward a supply that stages from 1.7 to 4 kilograms a year. The difference between depending on a single fragile source and having one of your own. And third, the neutrons themselves. Fusion throws off neutrons at 14 mega-electron volts, far more energetic than anything a fission reactor produces. That's usually treated as a problem to shield against, but it's also a resource almost no one can supply. The qualification environment that every future fusion material, every first wall, every blanket, has to be proven against before it can be trusted. Hyperion is, among other things, a test stand for the whole field. Notice the pattern. quantum computing, medical imaging, national security, advanced materials. None of these wait on fusion delivering electricity to the grid. They need the materials, and the materials are ready first. That's the strategic logic of breeding before burning. The value doesn't sit at the end of the road. It starts at the beginning. Once you have the fuel, you can build the machine that turns it straight into power. That's the burner. And it's a fundamentally different design from the breeder. It runs on deuterium and helium-3, a fuel that's low neutron, not zero. About 5.44% of its energy comes out as neutrons. We say low neutron, never a neutronic, because that's what the physics actually supports. The rest comes out as charged particles. And that changes everything downstream. The machine is a tandem mirror, a straight central cell, stoppered at each end by an intense magnetic plug. Those plugs are held by high-field Rebco magnets running at 26.49 Tesla. And importantly, that's about 0.82 of an already demonstrated field record. So it sits inside proven capability, not out past it. The plasma's charged products stream out along open field lines. And that openness isn't a leak to fix, it's the mechanism. They fan into an end tank and are collected directly as electric current. No boiler, no turbine hull, no cooling tower plume. You skip the steam entirely. We build this one machine in 2 housings for 2 customers. Aegis is for fixed defense installations, a base that powers itself. At the edge, the hardest problem isn't making energy, it's delivering it. The fuel convoy is the single largest force protection burden there is. A generator that runs on grams of fuel a day removes it. To be precise, Aegis is a fixed-site installation. Resilient base power, not a propulsion unit. MetroVolt is the same machine, packaged for the data center. Artificial intelligence is now the fastest-growing electricity demand on the planet. And it wants power that's firm, clean, and right next to the load. Faster than the grid can build transmission. MetroVolt sits on the campus, behind the meter, outside the interconnection queue entirely. We're equally clear about what isn't settled. The burner has one real physics gate, a thermal barrier of very hot electrons that makes the plug work. And we call it a gate, not a closure out loud. And MetroVolt's open item is helium-3 supply at true scale, which ultimately points off planet. That's external to us, and we say so plainly. One machine, 2 missions, and an honest ledger of what's proven and what's still ahead. You cannot control a fusion plasma by watching it. It moves in milliseconds. A person can't be in that loop. So Kronos builds the machine twice, once in metal and once in software. The software copy is the digital twin. The twin is a live, physics-based simulation of the whole machine. The plasma's shape, its stability, its edge, running in step with the design. It lets us fly the machine thousands of times before we ever build it, and find the failure modes where they're cheap, in a simulation, not in hardware. Two ideas do the heavy lifting. The first is the magnetic geometry. The nested flux surfaces the plasma rides on, and the separatrix, the last closed surface, the edge beyond which confinement ends. Read those correctly, and you know where the plasma is and where it's going. The second is a single number, the safety factor Q95, which tells you how twisted the field is and how close the plasma is to going unstable. Our designs hold Q95 at or above 5, a deliberate margin, not a coincidence. The twin also has to see the future, because reacting isn't fast enough. It predicts the plasma's state 50 to 100 milliseconds ahead. Enough lead time to act before a problem becomes a disruption. And this is where we're careful. The control stack is layered, and the division of labor is deliberate. Machine learning advises, but a deterministic rules engine decides. The rules hold hard physical limits. Normalized pressure kept at or below a beta N of 5.0, that safety factor floor, and they cannot be overridden by a model's suggestion. Intelligence proposes, physics disposes. One honest boundary. Today, the twin is validated in open simulation, checked against the physics and against published results. The validation against real machine data comes at our first hardware gate, G1. We don't blur that line, and we publish the twin so you don't have to take our word for any of it. A modern fusion plant produces more data every second than any control room could read. So Kronos is built AI native from the ground up, but with a discipline that matters more than the intelligence itself. Start with the sensing. A fusion machine is watched by a constellation of diagnostics: magnetic, optical, spectroscopic. Each partial, each noisy. The plant fuses them into one coherent picture of the plasma, cross-checks them for redundancy, and carries an honest estimate of its own uncertainty. So it knows not just what it sees, but how well it sees it. On top of that sits the intelligence. Learned models of the plasma physics run fast enough to keep up with the machine. They predict disruptions before they happen and suggest how to steer around them. But, and this is the line we will not cross, the AI advises, and a deterministic rules engine decides. Safety lives in physics, limits that a model cannot argue its way past. A human keeps override authority above all of it. Intelligence is a co-pilot here, never the captain. Then there's quantum computing, where we ask you to hold us to a higher standard of honesty than the field usually offers. Certain fusion problems, the quantum chemistry of plasma-facing materials, some optimization deep in the design, are natural fits for a quantum computer. We're building the tools to be ready. But we'll tell you plainly, there is no quantum advantage for these problems this decade. The hardware isn't there yet. We're investing in the runway, not claiming the plane has taken off. And we'd rather say that now than sell you a crossover that hasn't happened. That's the pattern for all of it. Powerful models, held inside hard limits, checked against their own uncertainty, and described exactly as capable as they actually are. Step back, and the whole thing is one cycle. The breeder makes the fuel and the materials. The burners run that fuel and make the power. The breeder's helium-3 is precisely what the burners need. The foundry feeds the fleet. Breed, prove, scale. 1 machine buildable now. 2 built to be ready. All pointed at the same purpose. Follow the physics in the order. It depends on itself, and it holds together. From the fuel you choose, to the shape that confines it, to the blanket that breeds more, to the plug that turns charged particles into current. Every step has a number, and every number has a condition. Which brings us to the part we care about most. Fusion has a trust problem, and it earned it. Decades of announcements that outran the physics. Our answer isn't a louder announcement. It's the opposite. We publish everything. The breeder and the burner designs are deposited in the open, with permanent identifiers, so the work outlives any slide we ever show. The analyses are reproducible, down to the byte, where we can manage it. And every claim wears a label. Shown, gate, or assumed. Demonstrated result. Acknowledged open question, or stated assumption. Named, never hidden. So when you weigh Kronos against anyone else in this field, don't take our word for it. Take our files, read the numbers, check their conditions, run the code. That's not a marketing posture. It's the product. A design you can actually diligence beats a press release every time. A family-owned American company thinking in decades, building the fuel and the firm, clean power the future is going to need, and doing all of it in the open. Kronos Fusion Energy.